In this lesson, we will explore the origins of gold, focusing on the geological processes that lead to the formation of gold-bearing veins and how these veins contribute to both hard rock and placer gold deposits. Understanding these processes is crucial for effective gold prospecting. Part 1. The formation of gold-bearing veins. Volcanic activity and magma chambers. Magma, or molten rock from deep within the earth, rises towards the surface, forming magma chambers. As these chambers fill, the pressure causes cracks to form in the overlying rock. If the pressure continues to build, the magma may erupt to the surface, creating a volcano. However, the focus here is on the cracks that form within the rock. Hydrothermal solutions and mineral deposition. Inside the magma, water and minerals are dissolved. As the magma cools, this water condenses, liquefies, and starts to move through the cracks. Groundwater, which is nearly ubiquitous on Earth, also gets involved, being heated by the magma and rising through the cracks. This hot water, now rich in dissolved minerals, is known as a hydrothermal solution. As the hydrothermal solution cools while moving through the cracks, it begins to deposit the dissolved minerals, a process known as precipitation. Over time, these minerals fill the cracks, forming veins composed primarily of quartz, along with metallic sulfides and occasionally gold and silver. Types of deposits, veins. A fully filled crack forms a vein which is a concentrated source of minerals, including gold. Disseminated deposits. When hydrothermal solutions move through porous bedrock, minerals can precipitate throughout the rock, creating a disseminated deposit. These deposits are typically lower in grade, but larger in tonnage, making them suitable for large-scale mining operations. Part 2. Identifying vein characteristics and sampling. Gold-bearing veins can vary significantly in composition, even within the same deposit. Observing the vein structure. Different layers within a vein may have formed during different events, leading to variations in mineral content. For example, a section of quartz may be nearly pure, while another section might be rich in sulfides and other minerals. Understanding these variations is key to effective sampling. Separate samples should be taken from each distinct section to accurately assess the vein's potential. Sampling tips. Always sample each distinct material separately to understand the different mineralization events that occurred. Consider sampling altered wall rock adjacent to the vein if it shows signs of mineralization. Part 3. The origin and types of placer gold. Placer gold is the result of the weathering and erosion of hard rock deposits, and it can be found in various forms depending on its proximity to the source vein. Residual placer. This type of placer deposit is found close to the source vein, where gold particles have weathered out of the vein and mixed with the surrounding soil. These deposits are ideal for metal detecting due to the relatively large size of the gold particles. Alluvial placer. As gold particles move downhill from the residual placer, they form alluvial placers. These deposits are found on hillsides and can be identified by following the concentration of gold downhill. Alluvial placer. Once the gold reaches a stream or river, it becomes part of an alluvial placer. These deposits form in the stream bed and are often concentrated in natural traps within the bedrock, such as bends or irregularities. Pay streaks. In stream beds, gold tends to follow a preferred path during floods, creating zones of high concentration known as pay streaks. These streaks are surrounded by sediments with much lower gold content. Understanding the formation and characteristics of both hard rock and placer gold deposits is essential for effective prospecting. By recognizing the geological processes that create these deposits and learning how to identify and sample different types of veins and placers, you can increase your chances of finding gold. Happy prospecting, and always prioritize safety while exploring.